So as I said at the end of last half term's chemistry lesson, we're going to move on from relative formula mass and RFM to more challenging topics within calculation within chemistry. So one of the first things I'm going to look at is moles. It is something hopefully a lot of you have seen before, and if you haven't, I'm just going to recap it. So moles is a ratio or a proportion, whichever language you'd like to use. It allows you to compare different amounts of elements and compounds. But I'm not really going to say that because those are kind of tough ideas. So what I'm going to talk about is the key principles. Mass must always be in grams. This is very different to physics. Just be careful. In physics, mass is always kilograms. Okay? So just be careful of that. We're always going to work in grams. And so I'm actually going to pick water. I'm going to turn around and say, right, I have got 18 grams of water. So I'm just going to make this question up. How many moles in 18 grams of water? Well, what has the molecular formula H2O? And we did some work on relative formula mass. To work out its relative formula mass, that's the first thing you're going to do is relative formula mass. I don't actually call it that, I call it MR. Right, and you'll see why in a moment. It's the same thing. In H2O, I've got two hydrogens. The big number at the top is 1. So I go, all right, okay. So I've got two hydrogens. So 2 times 1. And 1 oxygen, which is 16. Now, even though I've done that, I'm just going to double check. There you go. Oxygen, 16. So let's tidy this up from last session. So oxygen is 16. All right. So you go, right. So my relative formula mass, or as I put it, my MR for water is 18. Now to work out moles, and always, I was actually having a discussion with a year 13 student today, always annotate or write down what you are doing. Now this doesn't mean in long sentences, okay? So for me, N, for shortcut, the shortcut for N is the number of moles. M is for mass in grams, and MR is relative formula mass. Okay, forgive the typing. And how you work out the number of moles, N, is by taking the mass, M in grams, and dividing it by MR. Well, we're kind of lucky here. We have got 18 grams of water. So at the next point, you substitute in N, number of moles, is equal to M, which is our mass, 18, divided by our MR, which is also 18. So the number of moles we have is 1. Okay, so I've left that example there. Now, that's the first thing you're going to do. The second thing, I'm going to introduce you to a really cool number. It's called the Avogadro's constant. And again, some of you may have already done this, and for some of you it might be the first time you're doing this. Avogadro was, how was this about? A long time, about 500 years ago or something. And the number is, I'll write it in pen actually, 6.022 times 10 to the power of 23. Okay, and I'm going to round that up, 6 times 10 to the 23. This is a massive number. It is 6 followed by 23 zeros. I'm not writing that down, that's why I love standard form. So Avogadro's constant is this number, and this number is the total, the total number of particles. And I use the word particles because then I can talk about molecules, atoms, ions, it doesn't matter. So the total number of particles in 1 mole. Okay, so that's that. The total number of particles in 1 mole. So now I'm going to give you another question. This time, right, how many molecules of water in, oopsie daisy, how many molecules of water in 36 grams of water? All right. So what you always have to do, and I'm just going to change my colour slightly. Okay, that should be able to do it for me. Change colour. Yes, I'll change. All right, I need to change colour from there. No, I can't. All right. So how many molecules of water? So I'm changing. I'll put this here. Always work out your number of moles first. That's a bit too wordy. Always work out number of moles first. That's the first thing you're going to do. Always work out the number of moles. First thing, write down number of moles equals mass over mR. Now, predominantly boys, but a lot of you aren't going to do this. And you're going to find it very difficult to, really progress far at science, because it's not because, and I'm not trying to turn around and say you're lazy, it's not. It's because, I was like that. I know what I'm doing, so I'll just do it. All right, so the number of moles in this case, our mass is 36 grams, N equals 36. And we'd worked out the mR of water up here, which was 18. So the number of moles is 36 divided by 18, which is 2. So I have 2 moles. Now, if 1 mole contains 6.022 times 10 to the 23, you multiply the number of moles by Avogadro's constant. Okay? Number of moles by Avogadro's. Should be a capital A, Avogadro's constant. Put that in the wrong place, isn't it? Multiply number of moles by Avogadro's constant. So the number of moles we have is 2. So it's 2 times, or I should really, the number of moles times Avogadro's constant. Well, that's what you do. So the number of moles is 2 times Avogadro's constant, 6.022 times 10 to the 23. And this should give you, I better get my zeros right, 1.2044 times 10 to the 24. So that's the number of molecules you have of water. This is the number of molecules of water in 36 grams. All right, and there you go. So that's the last part of what we'll be doing. So it's split into 2, because I can start my typing. Because some of you have already done RFM, you've done it with me a couple of times. Some of you have already done Avogadro's constant, but that's today's work. The work is here moles, and here Avogadro's constant. Okay, let's just expand that out. I don't know why I didn't. And here's number of moles. That's very short number of moles. Okay, and what I will say to you, there is an example up here, and I tend not to like these too much, unless they make perfect sense to you. All right, so don't worry about that too much. Okay,